So this is the second part of the June 2015 Edexcel M1 paper. Question 5 is a moments question. The first thing I look for in a moments question is if it's a uniform rod or not, which it is. So we can mark the centre of mass in the middle of the rod. We've got the mass is 25, so the weight is 25g, or 25 times 9.8. Okay, it wants a tension in both of these strings, and I think that's all we need, although it does tell us also that there's a particle of weight mass 60, so weight 60g placed at B. There, 60g. Let's call the tension at C TC and the tension at A TA. This is a fairly standard situation. I normally will resolve vertically because it's always an easy equation to get. TA, it's very hard to get that wrong really, it's just forces up equal forces down. TA plus TC equals to 25g plus 60g, so that equals to 85g. Okay, nice and easy. Now for the next part, I'm either going to take moments about A, there, or I'm going to take moments about C, there. Anywhere else, I could take moments about it, notably the middle or B, but it would make sense to take moments about A or C because I'm then only going to have one unknown in my equation. So if I take moments about C, choose arbitrarily, it's not really a preference between one and the other, then I can say the ones that are going clockwise are obviously this force here, the TA force here is definitely going clockwise, and so is the 60g force about, if I'm taking moments about C. So the clockwise ones, TA force times distance. Now the distance there is clearly 4.5. That distance is 4.5. Okay, so that's 4.5. Okay, that's going clockwise, and then we've got the 60g force is also going clockwise, but the distance is only 0.5. So that's 60g times 0.5. That must be equal to the anti-clockwise moment. Now this length here, because it's 2.5 either side of the centre of mass because it's uniform, and we've already got this distance as 0.5, so this length here is 2. So the moment of the 25g force, which is going anti-clockwise, is 25g times 2. Okay, so let's work with that a little bit. We have 9 over 2 times TA plus 30g equals to 50g. So 9 over 2 times TA equals 20g. So TA is equal to 40g over 9. We can leave it like that. It is actually, the actual answer is, the answer to two significant figures is 44 newtons, which would also be acceptable, and the answer to the other one is 43.6 newtons, which is also okay. Now once we've done that, of course we could take moments about the other one, but it's always easier, I think, to use the resolving equation. So that means that 40g over 9 plus TC is equal to 85g. So I've got TC is equal to 85g minus 40g over 9, and that comes to, if I work that out, that actually comes to 725 G over 9, which actually works out at 790 newtons. If we want to give the number to 2 significant figures or to 3 significant figures is also okay. 789 newtons. So it's one of those 3 answers there. So there we go, 6 marks for that question. Right, now to the next part. It says a particle is removed from Q and another particle is placed at B. So let me just tidy this up and do a new diagram. So for part B, we've got a new mass of M placed there. And of course the centre of mass is still in the middle. And we've got a tension here. We call it T. Now, the key thing to notice, if M is at its maximum, what that means is if we make it any more than that, it's going to start to tilt this way. It's going to start to kind of rotate that way, which must mean tension here equals 0. Like one of our Toppling situations. So tension here is equal to 0. So we have, so that's when T at A equals 0. So all we need to do is take moments about C. Now taking moments about C, we will only have the 2 forces counteract. That distance is 0.5 and this distance here is 2.5, not 2.5, 2 meters. So we have mg times 0.5 equals to 2 times 25g, or 25g times 2. And put them in the same order. So g cancels. So we have then m equals to 100 kilograms. It really is as simple as that. The key is just recognizing that T has got to be 0 there. Okay. And then it says the greatest tension. So the greatest tension will be when this is equal to 0. So we just need to work out T when, drop the pen. So when 10 equals to 0, when we need to work out the T, we can call it T max, will be when this tension is 0, when this has reached its maximum, because we can resolve vertically. If M is at its maximum and this is at 0, then we can just literally go look at forces up equal forces down. So T equals 25g plus mg. So, but M is already 100 kilograms, so 25g plus 100g, which is 125g. Okay, because forces up equal forces down. This one's equal to 0 in that case. The one at A is equal to 0. So T max, that will be at its maximum when this is at its maximum, clearly. Okay. So that is question 5 now completed. Let's go on to question 6. Okay, so here we have a vector motion question with constant velocity in 2D. We've got given an equation of motion here, which has been separated out. We might be able to work backward. Well, we can work backwards here. And so that's minus 3i plus 4j plus t times 2i minus 5j, which actually answers quite a lot of the questions in itself. Basically, we can answer, we can see that the initial position vector is that. Or we can just put t is equal to 0 in here, and then that just breaks it down to minus 3i plus 4j when t equals 0. We can just do it like that as well. Okay, so that's part A. It says a particle passes through the point with position vector 3i minus 12j. So we've got the I bit governed by this part, so we can just equate the I bits in the two bits and find which time what the particular value of t gives us 3.4. So we can just equate 2t minus 3 is equal to 3.4. So 2t is equal to 6.4. T equals 3.2. That's the answer. Okay. Or big T they've used, so we better use the symbols that they've used. So that's 2t minus 3. So that's 2t and t. Now that's the answer, 3 marks, 3 easy marks. It might be worth checking to see, because obviously we could have equally have used the j, and that might be a useful check to check that we've gone right, because if they're not the same, then we know something's gone wrong. So 4 minus 5t equals minus 12. So we have 5t, 5 big T equals 16, which gives me t equals 3.2. So very easy to do. It's such a quick question to do, so we might as well take the opportunity to do a check. Now, the velocity of this, I've already done the work really by separating it out for part C, and I used it for part A as well. But for part C, this is the velocity. Okay, so the speed is just going to be equal to, using Pythagoras on that, 2 squared plus 5 squared. I tend to ignore the negatives in that because they just come to positive anyway. So it's the square root of 29, which is equal to 5 point, if we better give 3 significant figures. 5.39. Okay, meters per second. That's it. Question 6 is done. Nice easy question. Okay, so we've got a speed time graph here. We've got something moving along a track and it's accelerating with an acceleration of 0.5 until it reaches a particular speed. Then it's going at a constant speed and then it starts to decelerate. So we're going to have a situation like, let's do a different curve tool. Okay, it's going to be accelerating in constant speed and then decelerating like that. Okay, and the speed it's going at is v, and let's call that speed and time. Okay, I think that's all we really want. So the motion of the trace between 2A and B doesn't really, don't really need to show anything else at this stage anyway. Right, okay, moving on to the next part. So it wants expressions for the different times. So T1, let's call it T1, which is the time that it is during its accelerating phase, T2 when it's decelerating, and T3 for when, T2 for when it's going constant velocity, and T3 for when it's decelerating. So when it's accelerating, well, remember gradient, acceleration equals gradient. So we've got V, we're told the acceleration is 0.5, so we've got V over T1 is equal to 0.5. Okay, so that times by T1 on both sides divided by We have V is equal to 0.5 T1 divided by 0.5. That gives me T1 equals 2V for the first part. For the second part, we've got, it's a gradient as well, but it's negative, so it's just this number divided by this number. So this number, sorry, whatever that is, which is V, divided by this number. So we've got V over T3 equals to 0.25. So V is equal to 0.25 T3. So divide by 4, we get T3 is equal to 4V. Right, final part. Now it tells us some information about the total time travelled, I think, somewhere. 5 minutes from A to B. 5 minutes is 300 seconds, because remember we're working meters per second here. So we have T1 plus, for the third part, T1 plus T2 plus T3 is equal to 300. But we know with T1 and T3, so that's 2V plus T2 plus 4V equals 300. So that gives me T2 is equal to 300 minus 6V. Okay, so that's part B done. Part C is using the fact that the area is given us the total distance. So the area underneath is distance, which is 6,300 meters. Right, now we might be tempted to consider each individual triangle here and the rectangle, but it's actually easier to work at the trapezium out, because we know that this length here, from here to here, we've already know that that length there is equal to 300, because it's the total time taken. We know that this length here is the one that we've got, which is 300 minus 6V. So we've got the two parallel sides, so we can work out the total area. So we're using the area of a trapezium, just in case you don't know where I'm getting it from, equals to half of H times by the two parallel sides. And we know that's 6,300. Now H in this case is V. So we have half of V plus 300, which is the distance from here to here. Okay. Plus 300 minus 6V equals to 6,300. Okay, so we can double that and just multiply various things out. So we have V times 600 minus 6V half equals 6,300. I haven't actually done anything there really, apart from add the 300 together, but that's okay. Now I can times by half V, so I'm going to get 300V minus 3V squared is equal to 6,300. So let's manipulate that carefully. 3V squared minus 300V plus 6,300. It's natural, we want to divide by 3. And that divided by 3 is going to be equal to 2,100. And that factorises nice and easily 70 and 30. But you'll see quickly that the 70 is not appropriate. It doesn't apply, because if we have V as 70, then we have a negative term here, so it's a complete mess. And in any case, the question tells us that V is less than 50. So the only one that's actually valid is V equals 30, which is the answer to the question. Okay, so we're on to the last question, question 8. Okay, so next question is relatively standard dynamics. Final question, quite long, 11 marks, so we must make sure we're accurate. As soon as I see an angle mark like this here, there's a temptation to work with the angle. So okay. Okay, apologies for a slight pause there, the pen wasn't working. Again. Okay, so hopefully that's it now. What I'm trying to say is that I'm always tempted, when as soon as I see an angle here, there's an overwhelming temptation, well, desire, whatever, to change to sine and cos, because I'm undoubtedly going to be working with the sine and cos of this angle. It's arc tan 4 over 3, or inverse tan 4 over 3. Using Pythagoras, that's 5 there, so that gives me cos alpha equals to 3 over 5, and sine alpha is 4 over 5. Your calculator will do it as well, but I'm going to work with those exact values rather than see angles of 36.9 and or whatever in my work, and we're going to come back to that in part B, that point. Right, now it tells us the masses of these two things. The mass of P is 4 kilograms, so the weight is 4g, and the mass of Q is 0.5 kilograms, so the weight is 0.5g. And then we've got tension same throughout the string, because the pulley is smooth. There will be a tension pulling back on that, which will go towards part B, but let's leave part B for the moment. So we've got tensions going in that direction. It tells us somewhere that it's actually moving down the plane, and it's on rough ground and is inclined to that angle, and it gives us a coefficient of friction 0.5. Hangs freely, the string lies in vertical plane, and line of greatest slope, a particle is with and starts to slide down the plane. Took me a while to get there, but it's going down the plane. So let's put acceleration down the plane there, which means acceleration is going upwards. Let's mark on the other forces. The reaction force there. Now it's moving down the plane, so friction will be up the plane. Because it's moving, it will also be limited. In other words, it will have reached its maximum value. So I will put it on directly on my diagram there as mu r, and we're told that mu is 0.5. Right, so let's mark on this angle here. That angle there is alpha. So let's resolve perpendicularly to the plane first, and that just gives us the force perpendicular to the plane here. We've got that component there, because it's marked with the next to the marked angle is cos, so that component there will be equal to 4g cos alpha, which will be balanced with the r here. So that gives me r equals to, and we know that cos alpha is 3 over 5, so that gives me r equals to 4g times 3 over 5, so that's 12g over 5. Okay, and then I'm going to apply F equals ma to each of these particles. Let's do it to P first of all, which would be the slightly longer one. F equals ma to P. Always tend to apply in the direction of the acceleration, in what direction it's going. So force, the only force that's going down the plane there, is the component there. But because it's away from my marked angle here, that means it's sine. So that component of this force here is 4g sine alpha. Okay, because it's away from the marked angle. Now, but up the plane, I've got both of these forces here, which is minus t minus 0.5 r is equal to the mass, which is 4 times by the acceleration. I'm going to tidy this up before I get to my next F equals ma equation, which will be easier, which is the one for this particle q here. But let's just tidy up, because we know that sine alpha is 4 over 5. So we have 4g times 4 over 5. 4 over 5 minus t minus 0.5. Okay, apologies for the phone. 0.5 times r, and I've now got r as 12g over 5. So I'm going to do a bit more work on this and tidy up first. So that's going to be 16g over 5 minus t minus 6g over 5 is equal to 4a. So that gives me 10g over 5 minus t equals 4a. Just means I'm going to be able to work with it easier in the next part of the question. So that's so now I'm going to do F equals ma to q. That's much easier because I've got the force upwards, which is t, and the force downwards, 0.5 g, is equal to 0.5 a. Right, well, I'm not normally we're asked for the acceleration in these questions, so we'd add the two and work out the acceleration first and then put back into t, which you can do if you want, but we can see easily here that I can double this, easy to get an expression for a, and substitute for a might be as well. So 2t minus g is equal to a. So I can now substitute that into a. So we substitute for a into this expression here. So that's 10g over 5 minus t is equal to 4 times 2t minus g. So that's 10g over 5 is equal to 2g, of course. Don't know why I didn't simplify that before. 2g minus t is equal to 8t minus 4g. So that gives me 9t equals to 6g. So that gives me t is equal to 6 over 9g, or 2/3 of g. And we can leave it like that. The other two possible answers that they will accept, two significant figures, 6.5 newtons or 6.53 newtons if you're going to give 3 significant figures. Nothing else will do. And we tend to be a little bit tolerant about not giving units. Okay, so that's part A. Now part B, as I did mention earlier, is about forces on this pulley here. Okay, there's only 4 marks for it. I'm going to do a diagram. We now know T is this, and we know this angle. Let's just draw the thing again. Actually, let's try and make it a little bit more to scale. So we don't get put off. The actual scale is a little bit more like this. Not quite, because it's 10 alpha 4 over 3. So we've got two things pulling down on this. We've got a tension here and a tension here on the pulley. And we know what the tension is. We also know what this angle is. Okay, oh, it's not alpha, because alpha is here. Okay, it's 90 minus alpha. Okay, that angle there. And we can say what it is, but if I call it theta, we can actually work around and work around with it exactly. But we'll find that angle to be equal to 90 minus alpha, and we can work numerically if we want. Let's just work numerically first of all. Make sure you use a memory on your calculator. So we have (2/3g) coming down here, and 2/3, let's put the arrow in the middle, 2/3g coming down here. Okay, so now this angle here, I'm going to go back to this angle here, because the distance we've got, if we did our 3, 4, 5 triangle again with alpha and theta again, this distance here being 3, this distance being 4 here, this being 5 here, this angle here is actually equal to, let's call it theta. This angle here gives cos theta equals to 4/5, and we can work that angle out. Or you could have just taken your original alpha from 90, and that angle works out as 36.9 or something like that. Okay, use the memory on your calculator. I think it's 36.8698 and various. Just use the exact on your calculator. Now anyway, let's get on with the question. What we're doing is the resultant of those two will be whatever this diagonal of this parallelogram, let's do a different colour for it, will be. There. Now, probably the easiest way, you might use a sine rule, but probably the easiest way is to work this length out and marking on the diagram here. Okay, working that length out and then doubling it. So the force on the pulley will be equal to 2 times, because we've got 2 lots of these, there and there, this angle, which is half of 36.9, so that will be, and the cos of it, so it's 2 times the cos of half of this number 36, it's not exactly 36.9, it's 36.86, blah blah blah, hopefully a number that you stored on your calculator, divided by 2, because that's the whole of that angle there. Okay, and that number comes to 12 newtons, or times by 2g/3, of course, because that's the length of the side. Okay, so, and that equals to 12 newtons. So 2, because we're doubling the sides. This is the length of the side. It's probably written a bit the wrong way around, really. Let's do it again. It's the length of the side, 2/3g times by cos of that angle there, 36.8 blah 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 over 2, and we're doubling that because we've got 2 of them. We're working with 2 of those in that diagram there. And that comes to about 12 newtons to 2 significant figures, and or 12.4 newtons to 3 significant figures. Right, okay, so that diagram is a bit of a mess, but never mind. Incidentally, for those who want an exact answer, really we need to use C3. So some C3 trig would give us an exact answer for those of you who've done A2 and are doing M1 later. Then I will show you how to get the answer exactly. But it's okay to just use just use the numbers. Make sure you use the memory on the calculator efficiently. So let's just try and work out the exact thing again. I'm going to draw that diagram again because I've made a bit of a hash of it. So we've got this angle here, we've got this force here, and that's 2g over 3, 2g over 3. And we're working out what the length of this diagonal is. And I'm going to mark this angle here, and I'm going to call the whole angle theta as we did before, where cos theta is 4 over 5. Remember theta, go back to the original angle, we can mark this angle here. Right? So cos theta is equal to 4 over 5. So this angle is theta over 2, because it's half of it. And again, we can see that the resultant force on pulley, again, will be equal to basically double this length here. Just doing the same thing again. Just working towards an exact answer. So that's double times by the length 2g over 3. Okay, times by cos theta over 2. Okay, right, now we've got cos theta and we want to have cos theta over 2. So those who've done C3, as promised, we know how to do that kind of thing now. If we've got cos theta equals 4 over 5, using the double angle formulae, we know that 2 cos squared theta equals to minus 1 equals 4 over 5. That gives me 2 cos squared theta over 2, sorry, that should be over 2, over 2 is equal to 4 over 5 plus 1. So 2 cos squared theta over 2 equals to 9 over 5. Cos squared theta over 2 is equal to 9 over 10. So cos theta over 2 equals to square root of that, which is 3 over the square root of 10. Okay, so going back to here, that gives me the resultant force on the pulley is 2 times 2g over 3 times by cos theta, which is 3 over the square root of 10. Cancel out the 3. So that gives me 4g over the square root of 10, which is which you'll see is a more accurate and exact answer. If you don't like, we don't really like square roots on the bottom, so we can rationalise that. So that's 4g the square root of 10 over 10, or even better, because that cancels down, 2/5 the square root of 10g is an exact answer. But that's not required for M1 really, because you're not expected C3 knowledge. So use your memory on the calculator, do a bit of trig, get a diagram, and you're done. Okay, so I spent a bit too long on that last question really, and a few technical problems, but we've finished now. That's the M1 2015 done, and that's it. Hope you enjoyed it. Thank you. Bye.